Hi, my name is Mark Planaguma. I'm the head of data engineering in Lidl SUM International Hub. And I'm here to explain the further the platform architecture and as an implementation of a Lakehouse and also other architecture patterns. Then let's go to see what is inside this solution. And far at the end, it's a success story of build a data platform that could be considered a lake house inside a big enterprise as is as Bars Group, that is more famous to be the owner of the Lidl supermarkets. Well, this is important for the context because Lidl and Sparks Group is the third retailer in the world, just behind Walmart and Amazon. Is the first one on Europe, and is really big retailer. It's not a digital native company still yet, but it's true that we was finding a way to build this project on a most native environment as possible. And then for this reason, we can share with you the context where was built this Phar data platform. Then this starts as a spin-off called it SCRM, was completely owned by Lidl, but was a split from the organization and from the structure of Lidl, providing a greenfield to build an organization and products in a most digital native way. Then this starts around 2016 in Barcelona, split it from Lidl, and in 2019 was part of the organic of Sparks Group, becoming Lidl International Hub based on Barcelona. Then with this context is where starts the goal of this company to build the loyalty program of Lidl. It's called Lidl Plus, and is the loyalty product of Lidl, and is fully designed from the beginning as a digital concept. And at the end, as all the loyalty programs, it aims do a data exploitation, crossing the user data wall with the product data wall, trying to de-anonymize the purchases and don't have anonymous purchases, have purchases related with the user, and mix these both walls, the user data wall and the product data wall. Then for this reason, this hub have the goal to build this loyalty program, but also have the goal to explore and extract insights from this data. Then well, this is the context, and this is the goal, and you was using this greenfield to build our own data organization, our own data team, to as a main enabler of build our own data platform. Then let's see what's the challenge that we was trying to solve with this Phar, seeing the challenge and the goals. Well, first of all, we was in front of the same challenge or problems that have a lot of companies that have a lot of data and also have a lot of teams that wants to create products on top of this data. These teams start getting data from the sources, from the transactional systems, even in some cases do the analytics inside the operational systems, but these could be provide a lot of problems, as you know. But we was trying to solve all these situations because these vertical integrations about each team getting the data from the sources was a big number of integrations to maintain, was impossible to solve the data consistency, the data quality was something really hard to do and really split it on each project. There was no monitoring about how is going on everything. That centralized data access data management was not possible. Even share data was a nightmare between them, and the time to market for these projects was really slow. Then we was trying to solve all these problems with this Phar concept, but not only creating a platform, not only creating technology. Our idea, it's Phar as a product, it's a platform, but it's a data market at the same time, working and playing together. Then to achieve that, the idea is the end, the final goal is this analytics democratization for the different teams. That this at the end means that we want a lot of different departments and different internal teams in the Sparks group able to explore and create a lot of products autonomously, one each other. Then our main goals to achieve this analytics democratization was build a platform and a market that provides this ingestion capabilities, this engine that scales on batch processing and streaming processing, cross services like security access, monitoring, logging, governance, and lineage, and mainly these workspaces where all the teams are able to work independently and get this data and build their own data products on top of this platform. Okay, we know exactly the challenge that we want to solve, the goals that we want to achieve, a little bit the structure about our features, but let's see how to achieve this data market and data platform bringing together. Let's put the typical data journey of analytics, that we have data in the input, we have analytics on the output, different kind of analytics, BI, advanced analytics, machine learning, whatever. But to achieve that, we was creating an organization and thinking that in the first features that we need to provide to this solution was technology assets, like different tools and frameworks, the infrastructure provisioning, security and access solutions, logs and metric solutions. We was starting to work on these areas to provide solution on that, but as well at the same time with this also focus on governance, providing features like contract modeling, data market modeling, and the data feeding itself, because if we want to provide a platform that is a technology, but that includes data inside, we need to do the feed as well. Finally, we achieve this loyalty customer data market, a 360 view of the user data and the product data in the same place, ready to be used as an analytical workspace and a BI environment, and also providing the data as an output. Then this was the goals and the vision of the platform, but we can do a zoom in also in the details of the data market. This data market, in our case, is divided by layers, and each layer is a specific market. We have the first layer that is called raw, will appear during this presentation a lot of times. This is a kind of gross market. This layer is not accessible. It's just for historification, and we are storing the data as arrived to make a copy of everything and to be able to reproduce everything that is arriving to the platform. Then the first layer that is accessible by the teams, analytical teams, is the L1, is our primary market. It's event based. We have a big collection of events there. The users are able to consume as a market all the data that is in the platform. And then we have the last layer of the market is this N layer, and is the domain market that is based on use cases. This is split with different spaces for each team, and each team is able to get the original data from L1 and create their own models and share with others. Then, in terms of market, the people that is using Phar have accessible all the data, all the primary marketing in L1, and a lot of domain markets generated by the different teams using the platform. Well, we know right now that the concepts that we are following to build a platform and build the market at the same time, but this session is about architecture, and we will show the architecture that is behind Phar and the different contributions of different patterns and paradigms of architecture that are in the market that we are using and adapting in our platform. Let's start with the layered architecture. Layered architecture is a famous architecture used not mainly on the operational side, on applications, but we have some adaptation in our analytical platform. In the layer architecture, we exist this presentation, domain, and data stages. We transform this on this data hub, data market, and analytics workspace stages. Let's see in more detail what means these stages in our proposal. Well, we have again the journey of the data from the source to the product, and we are moving this data through these different pieces inside the Phar product. First, this data hub a stage where the data is arriving and is extract from the source and is make it actionable from the source. Then it's promoted to the data market where this data is put it available for the final users. And we as well provide a place where work with this data, create their own models and create their own products. Then as a platform, we have these stages with this part of the platform. We are providing cross features like architecture, framework and tooling, security monitoring for all these stages. But then there are features that are concentrated in part of these stages. Also, we are working on governance, focus on the data hub and data market part, because at the end, this data hub is where the data comes, and we will define after, but this data comes in defined by contracts. And then the data market is offering contracts as well for the customers. Then we need to control the data governance to make it to make actionable this data on data hub and data market. And then we have another feature that is the actionability on data market and analytics workspace. We need to work to make it feasible and friendly, the job of the data analytics teams. That means we need to make it interoperable, all the market between them, and we need to provide a scalable platform where to process the data in the analytics workspace. Now we can jump in another approach. This approach comes from Databricks, is the data lake approach, and is famous for these layers, the bronze, silver, and gold. Also is focused on used Delta Lake. The Delta format we are using in some part of the platform, not all of them, but it's true that we have the equivalence of these layers. Bronze is our raw, silver is our L1, and gold is our N. But let's see the detail. Well, for us, the journey, the data starts from the source, is ingested on raw, is integrated on, that is our bronze, is integrated on L1, is processed on NN, and is consumed to the product. Then for us, raw is providing this esterification, L1 is providing the market where the data is available but is in a raw value, and NN is providing this gold area where the people can prepare and put the data more close to the business, more close to the use case. But we can see these layers in another way around, in a kind of layers in circles, because all the layers at the end contains the other ones. Let's see then the difference. For us, we have this data ingestion in the beginning. We have this first layer that is raw. Raw is based on events, and we have stored all these events following a specific contract. We have a contract for each input, and we are storing these events in a raw format as the contracts define that this data will arrive. Then we are promoting this data on L1. L1 is a public market and is classified by entities. Is providing a concept that it's providing Phar. It's a concept provided by Phar, that is the Semantic Lake. we are classifying this data that arrives in raw in different entities, depending the meaning, the semantic meaning of the data, but make it actionable one each other, but not touching the value. That nothing is aggregated, only is classified to be consumed. And then we have the NN, that is a working space available for the customers and create their own models. Then it's a way that can be done specific models for specific products, BI models, advanced analytics models, whatever the teams wants to do. Well, after saying these layers, we can go also, and another approach of architecture is this event-driven architecture, where we are getting some concepts, but only for a part of the platform, not for everything, but is a really core part of the platform. That is the beginning, is the data hub. The idea of the event-driven architecture, it's based all on events that arrives on a data store, and there are some subscribers getting these events that are stored in this event store or broker to fulfill different kind of platforms. That is also our idea on the data hub part. We have the sources, batch sources and real-time sources that are sending messages, objects to our data hub that contains a couple of landing zones, the batch landing zone and the real-time landing zone, but the input is controlled by contracts. This means that each message or each data that arrives in the platform is defined by a contract with a lifecycle management, with version control, and we are able to check if this message is fulfilling the schema or not. For both sides, for real time with single events, and for batch with files that contains inside a collection of events. And then after this data hub, we are able to feed our data market, but as well, we are able to feed other platforms interested to consume this data just with the raw value from the beginning. Well, let's put this concept as well in our layers. Then appears a new layer more, this landing zone, and we can do the journey again. We have this ingestion from the source that arrives in our data hub. It's this force that this data will arrive on event based, okay, fulfilling specific contracts that we did and we define. Then it's validated. We are able, with this contract, able to validate and put this data on raw, store these events on raw, promote and do the integration to build the data market, and then we prepare and make actionable this data for the different teams in the NN and top layers. Another one architecture where we are getting concepts is the Lambda architecture. Lambda architecture is a famous architecture from Nathan Marks that combines the batch of analytics with streaming analytics, and we want from the beginning exactly the same capabilities. We are building a batch framework and a streaming framework. This means that these layers, landing zones, raw, L1, and NN, we have these layers in both walls. We have a streaming landing zone, raw streaming, L1 streaming, and N streaming, and the same for batch. So landing zone, raw batch, L1 batch, and batch. The idea is reproduce the same stages, but provide technologies that specifically for each framework, and also provide a way how to combine. And this is what happens on our workspace. This workspace is created by Databricks. At the end, it's a really nice feature that is providing Databricks to us, because on this Databricks workspace, we have connected the batch framework and the streaming framework as well. For streaming, raw and L1 are Kafka clusters with Kafka topics. And for batch, we have the data on a distributed file system on Azure Data Lake, and on raw and L1. And this means that have this connected and provide this connected on the same workspace, the teams are able to consume the Kafka topics and the files and the entities from Azure Data Lake on the same workspace and are able to use Delta Lake, for instance, to cross this batch data market and this streaming data market. Then we have these layers getting concepts from different places. We have these capabilities to do batch and streaming at the same time, but we are following another approach as this multi-cloud native approach. Why? Well, mainly because our platform is fully built on cloud. It's mainly built on Azure, because in the beginning was the unique cloud that was available for us, but then was starting to be available as well, Google Cloud. And right now, to put an example, here we can see another way around our architecture, that in the bottom line, there is the data hub with landing zones. In the middle, there is the data market with batch layers, raw layers done with Azure Data Lake and Kafka. Databricks is in all the stages to transform data. We have the Hive Metastore that is as well in Azure. But we have also our scheduler that is Google Composer. As you know, is an Airflow as a service from Google. And this means that our platform is built with cloud services, but in this case, services from different clouds. We have the scheduling coming from Google, and the storage and the computation Databricks provided by Azure, and all put together and really connected to only provide one solution. Let's go then for the final paradigm, because we get different concepts from different classical patterns, but also we are getting something from Lakehouse. Then the question is, ask if Phar is a Lakehouse, because Phar starts to be built and be designed before appears this paradigm, before we make it public by Databricks. But well, the ideas was really close, and it's true that after this release, we was also getting some features of Databricks helping to be adapted and be more close to be a Lakehouse. Then we have this idea of mixing data warehousing and data lake, but let's put the concepts and the stages of Phar in top of this diagram. We have the data hub in the bottom, actually getting the data from the sources, a lot of kind of data, but in our case, defined by contract. We have the data market, preparing and make it actionable and ready the data for a lot of consumers. And we have this workspace that are already used by different teams like BI teams, data science teams, analytics teams that are already in place working, creating their own products in top of this market. Let's see more detail, because at the end, Lakehouse is fulfilling some key features, and let's see if Phar is fulfilling these features that Lakehouse concept is doing. In the beginning, we have this support for different kind of data types. We are supporting all the data types that can be defined in a contract. Everything, structured and not structured, can be arrived on the data hub, it can be ingested. We have the storage and compute decoupled, because we are working on cloud, and we have the different services, the storage and the computation on Databricks and Azure Data Lake. We have a strong schema, enforcement and governance. We have a validation in the beginning. We have a contract in the output. We have a full quality check in the middle. That we are doing a lot of effort, and we are providing a lot of tools to do this governance. We are openness, because in our market, it's not based on Parquet or Delta, like is defining the silver layer or on the data lake approach. But we are working on ORC and on L1, but we are putting the data interpretable in one format. Then we are achieving this feature as well. We are end-to-end streaming. This means that we are providing these streaming features. This transactional support is available and using Delta. We are already, all the dashboards in loyalty program are built on top of the Phar data platform. This means that we are providing BI support, And we also have some other diverse workloads like recommender systems, forecasting tools, fraud detection in top of the platform. Well, seeing what we achieve from these patterns is a moment to explain what we are putting on top of the table as something new in this platform. The first thing is this concept of semantic lake. This it's the focus on the L1. As you can see in the row, we have a data types collection. It's a collection of events defined by contracts that at the end are merged in these entities. The entities are big ORC tables with the schema and the metastore that have a kind of semantic classification. In this case, you can see example that all these events related with user tracking arrive to the entity fully dedicated to the user tracking. Then this semantic lake is providing a market with some tables with all the events with the raw value, but classified by domains. Then the data contracts. We have data contracts in the input. We have data contracts in the output. Data contracts in the input are the data types, these events defined by contract and with version control. And then in the entities, these tables also have their own control and version control. And the metastore is the contract that we have also in the data catalog, and we provide as market, as a stable market to the users. This is another concept new in our platform. And at the end, another concept is this workspaces with the multi-tenant metastore. This is a extension of metastore that we did internally in the team in order to achieve that these workspaces, all of them are able to read the L1 market, but also are able to decide if they want to make it public, private, and shared, the schemas and the models that they are doing on the end layers. Then doing this change extension in Hive, the data and the schemas that appears on Databricks, each team is able to decide if they want to make it public, read for everybody, private, only for the specific team, unshared, that it will be read for a specific teams that they want to share. Finally, some numbers and some lessons learned. Well, first numbers, the Phar have data from 26 countries where the loyalty program is working, have the data from more than 30 millions of users that are using right now the Lidl Plus in Europe, that in the near future will be available as well in the States, have actionable data on the market close to the 700 terabytes of data, event-based, and right now have more than 20 teams doing analytical products like recommender systems, fraud detection, machine learning to create automatic coupons, wherever. Another point is this, how we achieve it. We achieved this not only doing architecture, we achieved this doing teams, and these teams are mainly focused on these three teams: the data platform team, the data management team, and the machine learning team. These three teams at the end are part of the big family that is doing Phar, and we have these overlaps that helps a lot to us to build this platform. From data platform teams and the data management teams, we have this governance that we are doing together. From data platform team and the machine learning team, we are working to make it more actionable and make better and bigger this platform and the tools that are providing. And for machine learning and data management teams, they have this overlap to try to make the data more close to the asset, to be a product. Then these three teams at the end are the core reason to build this Phar data platform, and this platform that is also available for a lot of other teams. Each of them have their own goals, but all together are creating the platform. And finally, it's the insight that when we become data-driven, and the architecture part helps a lot to us because, as I said before, Phar data platform is saying that we need to do a data contract in the beginning. This means that the analytics effort starts in the source. When we need to do this contract, when we need to analyze the data that we want to extract, is when it starts this data-driven thinking. Then And this was accelerated a lot when the producers and the consumers starts to being the same actors. Because when a consumer wants to, when a data producer wants to get some insights from their own product, are really interested to fit in the best way the platform. And at the end, this feeding, starting analyzing and defining the analytical objects from the beginning is, from one side, it's helping a lot because the data is more clean in the platform, but in another side is helping a lot in achieve this data-driven thinking. And that's all. Thank you so much. Here you have my contact details, and thank you to attend on this presentation.